This is lesson C41, Insurance Percentiles and Probabilities. In this section, Miscellaneous Topics, we'll have two lessons. The first one will be on Insurance Percentiles and Probabilities, and the second lesson will be on the relationship between discrete and continuous insurance. In this lesson, we'll talk about percentiles, and we'll find the probability that the single benefit premium is sufficient. Let's jump straight into percentiles. Percentiles is one of those topics that students just struggle on a lot. So what I want you to do is really focus in, put your thinking cap on, and we'll walk through these percentiles very slowly. We're given that mu is equal to 0.03, so that's constant force, and delta is equal to 0.07. And we're asked to find the 80th percentile of some random variable z, where z is v to the tx, and tx is greater than 0. Remember, tx is the future lifetime of somebody age x. Do you remember what present value random variable this is? Or what type of insurance this is? This is whole life insurance. Whole life insurance says pay $1 when a life age x dies. And if I pay $1 when they die, and they die tx years into the future, then the present value of that dollar is just v to the tx. So here we have whole life insurance. So I'm trying to find the 80th percentile of this z. So that anytime I try to find a percentile of any random variable, the first thing I do is graph all the possible values for that random variable. So let's do that now. Remember, that graph is called the pain curve. So on the y-axis I put the present value random variable, and on the x-axis I put the future lifetime. So for instance, if the person age x died immediately, then the pain to the insurance company would be 1 because I'd pay $1 immediately, and the present value of that dollar then would just be $1. And then these are all the other possible values, e to the minus delta tx. So my 80th percentile is one of these values on this red line. I don't know which one it is, so I just chose a point and said, let's let that be the 80th percentile. Remember, this curve is v to the tx. And so this point occurs at one of these future lifetimes. I don't know which future lifetime. Let's just call it h. So this is going to be the point h v to the h, and then v to the h will be my 80th percentile. So let's label that point h v to the h. So the answer to my question is v to the h. That is the 80th percentile. V to the h just says discount for h years. So that's e to the minus delta h. And in this case, delta is equal to 0.07. So the answer to my question is e to the minus 0.07 h. However, I need to find out what h is. To do that, I'll apply what the percentile means. Do you remember what the percentile means? It means we take on that value or less 80% of the time. So here, this point right here is my percentile. So the question is, which of these values on the red line are less than that point? Is it to the left or to the right? Of course, it's to the right. The ones to the left are larger. The ones to the right are less than that point. So everything in this blue box are values of z that are less than v to the h, which is my 80th percentile. So that means I must take on these values 80% of the time. How do I take on these values? Well, I take on these values if my x values, and remember x is t to the x, or t sub x, if t sub x is greater than h. Or in other words, if the future lifetime of somebody age x is greater than h. What was the probability of that? That was simply HPX. So HPX must be equal to 80%. So now I can use this equation to find h, plug h back into here. That will give me my 80th percentile. So let me go through that one more time, just because I know it's very confusing for students. What I do when I'm finding a percentile is I draw the pain curve. So we did that. And then I label one of the points on the pain curve as whatever percentile I'm trying to find. So for this problem, I'm trying to find the 80th percentile. So I let this big red dot be my 80th percentile. And then I say, okay, so that's my answer, v to the h. I need to find h, and I say, well, if v to the h is the 80th percentile, then I have to take on that value or less 80% of the time, or that value or more 20% of the time. I can write either one of those equations. In this case, we're working with constant force, so I prefer to work with HPX. So I worked with the less than v to the h 80% of the time, and I take on these values here, this part of the graph, only if the future lifetime is greater than h. Well, the future lifetime is greater than h, the probability of that is HPX. So HPX is equal to 0.8. I could have similarly said, we'll take on this part of the graph 20% of the time, and the probability that I take on this part of the graph is HQX. So HQX is equal to 0.2 because that's the probability that the future lifetime is less than H. Well, the probability that the future lifetime is less than H is if life age X dies during the next H years. So HQX is equal to 0.2. So I can work with either one of these to find H. I'll just use HPX because I can simply write that as e to the minus mu H, and mu was 0.03, so that's e to the minus 0.03 H. Now, at this point, as if I haven't confused you enough, instead of directly solving for H, which I could do, I could take the natural log of both sides, divide by minus 0.03, that would give me H, plug it into here, that would give me the answer. Simple, right? I like to complicate things. I actually think it's simpler, but a lot of students find this more confusing. I'm going to do it anyways, just because I don't like to pick up my calculator until the very end of the problem. I try to go as far as I can and then pick up my calculator. And one of the reasons I think it's a time saver, and the other thing is I think I'm less likely to make careless mistakes. I may look at my calculator and crunch something and then write down something else on my paper, and now I've messed everything else up because I didn't copy from one piece to another. So for that reason, I just like to go as far as I can before I pick up my calculator. So how am I going to do this? Well, I want e to the minus 0.07 H, and I know e to the minus 0.03 H. So I'm going to write this as e to the minus 0.03 H. However, obviously those aren't equal. So I need to raise this to the 7/3 power. And the reason why it's 7/3 because if I take 0.03 and divide by 3, then I get 0.01. And then if I take 0.01 and multiply by 7, then I get 0.07. So I've kept my equation in balance. Now, e to the minus 0.03 H is 0.8. So this is just 0.8 to the 7/3. So crunch whatever that is on your calculator, and that is my 80th percentile of whole life insurance. Okay. So what